Step back about 100 million years, and Earth was completely unrecognizable. There were no humans. Instead, the planet belonged to reptiles, so massive they dwarfed their surroundings. They could run at speeds nearing 90 kilometers an hour, equipped with jaws that could crush bone in a fraction of a second. When British scientist Richard Owen first coined the term dinosaur, meaning terrible lizard, in 1841, paleontology was in infancy. Because we had only unearthed a few fragmented fossils, our initial drawings of these creatures were vastly different from reality, often depicted as slow, heavy, oversized iguanas. The ancestors of these massive predators first emerged around 230 million years ago, during the Triassic period. Back then, you couldn't sail between continents. Asia, Africa, Europe, and the Americas were entirely fused together into a single supercontinent known as Pangaea. Over millions of years, Pangaea split apart, and the dinosaurs evolved to fill every ecological niche on these new landmasses. By the Cretaceous period, they reached peak dominance. Creatures like the Tyrannosaurus rex emerged as apex predators, armed with the most powerful bite force of any terrestrial animal in history. For over 170 million years, they held. Through shifting continents and varying climates, dinosaurs remained completely adapted to rule the Earth. Then, 66 million years ago, a rock roughly 10 to 15 kilometers wide fell from the sky. It was traveling at 30 kilometers per second, 150 times faster than a modern jet airliner. It slammed directly into a shallow sea on what is now the Yucatan Peninsula in Mexico. In the blink of an eye, the undisputed rulers of the planet were erased. This collision triggered the fifth mass extinction in Earth's history, destroying more than 75% of all plant and animal species. Biologists today are focused on the mechanics of that ancient collapse because they have reached a consensus. The sixth mass extinction has already begun. The violent death of the ultimate apex predator provides the data we need to understand our own ecological vulnerability. The initial impact released the energy equivalent of 100 teratons of TNT, 1 billion times the explosive force of the atomic bombs dropped on Hiroshima and Nagasaki. Everything within thousands of kilometers was instantly incinerated. But continents shift and oceans rise over millions of years. This raises a question: how can we precisely map an event of this magnitude today? The planet holds the record in its rock layers. In formations all over the world, there is a specific global anomaly, a layer of iridium. This mineral is rare in Earth's crust, but found in high concentrations within asteroids. When carbon dated, it points to exactly 66 million years ago. This thin, dark band acts as a global fingerprint of the extraterrestrial strike. We can still see the 180-kilometer-wide impact site today. In Mexico, massive underground sinkholes called cenotes sit in a perfect ring formation, tracing the exact outer edge of the buried crater. These physical scars, the iridium layer and the ring of sinkholes, align to give us a precise reconstruction of the deadliest day in history. The blast itself was only the beginning. The explosion threw millions of tons of pulverized rock and sulfur into the atmosphere, blocking sunlight for over a year. The planet entered a nuclear winter. Without sunlight, the food web collapsed. Photosynthesis stopped, plants died, and a fatal chain reaction starved herbivores and carnivores. Survival was dictated by size. No terrestrial animal over 25 kilograms could survive without growing plants. This created a biological loophole for small omnivores. Turtles, early mammals, and avian dinosaurs survived by scavenging decaying matter and hiding in burrows to escape the freezing temperatures. The apocalypse for the giant reptiles created an ecological vacuum. By clearing the terrestrial landscape, it allowed early mammals to diversify and eventually evolve into the humans that rule the planet today. Humanity now sits in the exact same apex position that the dinosaurs once held, but we have developed a unique ability to track and intercept the exact type of cosmic threat that destroyed our predecessors. In September 2022, NASA's DART mission successfully collided a small spacecraft directly with an asteroid to alter its path. While deflecting a 160-meter rock is a far cry from stopping a 10-kilometer extinction event, it is a significant step. For the first time in Earth's history, a species has demonstrated the potential to actively intervene in its own cosmic fate. But the threat we face today isn't falling from the sky. We are currently causing the sixth mass extinction, known as the Holocene extinction. By aggressively clearing forests and destroying natural habitats, we are killing off plant and animal species at an unprecedented rate. Industrial pollution is suffocating the oceans and atmosphere, accelerating the normal extinction rate by hundreds of times. Global conventions have set urgent targets to protect 30% of the planet by 2030, but we are currently struggling to meet the goals required for halting the collapse. Consider the scale of our existence. Dinosaurs ruled the Earth for 174 million years. Humans have existed for only 300,000 years, a microscopic sliver of time in comparison. If we do not stop destroying the biosphere, we will act as our own asteroid. At our current pace, we will never come close to the survival record set by the dinosaurs.